Hello, everybody. Welcome to this webinar. As usual, we'll do a bit of a slower start because people are joining. It always takes a couple of minutes. Welcome to those of you who are, just joining us. Feel free to say hello in the chat. I'll just post a message. Yeah, great to see some familiar names again, some new names as well. Welcome if you are joining us for the first time, even warmer welcome. Although it's the same welcome for everyone. It seems like we haven't run this one in a while. We usually do 2 or 3 webinars a month. We had a bit of a longer break this month, or last month really, in October. So it's been 2-3 weeks really. So I feel a bit rusty. But yeah, great to see more people joining. So while we're waiting for everyone to join, maybe just a couple of sort of housekeeping rules. As usual, for those of you especially who haven't joined our webinars in the past, so we usually encourage everyone to use the chat option as much as you want. You can post your questions during the conversation, during the demo, at any point in time. Don't worry about waiting and until the end. Just post your questions as they come up for you. You can also use the Q&A option, which is a little bit better admin wise. It's just easier for you to see whether the question will be answered live or written, but again, it's completely up to you. We're quite flexible with that. And especially today, we've got we're going to have a bit of a chat, a bit of a demo, and we will be very much open for your suggestions, what you want to talk about in regards to the topics that we've got that we're covering today. It's all for you really to drive it for us as well. If you have any specific questions, anything that is particularly important or interesting, we can focus on that more. So please, let us know during the next hour. We are also recording this session, so for those of you who have to leave early or those of you who want to revisit later, this webinar will be available to watch as a recording on demand pretty much right after we finish. You can access it through the same link you've accessed it right now to join. And then in a couple of weeks' time, we'll also publish it on YouTube. So it will be available for you to watch and share. Okay, I think we are 3 minutes past, so I think we can start. And then if people join later, then hopefully they will be able to catch up with us. So so today hopefully you are in the right place. So just a reminder, this is the webinar about innovative concurrency, mastering Jakarta EE with Java 21's virtual threads. So our speakers for today are Lukman, who if you've watched our webinars before, you will be very familiar with Lukman. He's our Jakarta EE expert and our usual webinar host. And today he's joined by Peter, who is a Payara senior software engineer, and they both join forces to basically just talk about, this is quite a wide topic actually, so that's why we're asking for questions as well. So we'll be talking concurrency, Java 21, virtual threads, Jakarta EE, all of that. So I think without further ado, I will stop sharing my screen and I will leave the room with Lukman and Peter. So take it away, Lukman.
Yes, thank you very much, Dominica, and welcome, guys, to this very interesting discussion, virtual threads and Java 21. Arguably, Java 21 is the biggest release of the whole Java releases, I think, since Java 8, because there has been a lot of expectations about most of the things it came with, most importantly, the subject at hand today, which is virtual threads. Now, we are all interested in performance applications and all that, but also want to cut down on application runtime costs in terms of using platform threads and all that. So virtual threads seem to be a very good fit for most of our cases. But then, is it really a panacea? Is it really the silver bullet we've all been looking for as developers? We tend to always look for that one thing that can solve all our problems. And so we want to ask, is virtual threads really that? Is it that golden standard that we've all been waiting for in terms of application performance? So let's start our discussion by first looking at what threads are. Let me just ask Peter, since he's the resident expert on that. Peter, what are threads? When we say an application thread, what do we mean?
Yeah, threads help us to develop applications which are much more responsive to multiple requests done in parallel. So if we have more powerful computer which is able to run several tasks at once, it's definitely better to develop applications this way. Normally, we are talking about Jakarta applications, so this happens by default. It's built into the Jakarta framework. So it's mostly web applications. So the requests are executed in parallel. But very often it happens that one request is composed from multiple other requests, like database, some other web services mostly, some REST calls, and it's possible to run these tasks in parallel, and therefore allow to increase the performance, to lower the latency of the request, because the requests are done in parallel, and therefore they can be finished earlier. So that's fine. This is something which happens very often, and it was always part of the Jakarta. So what's changed now is the usage of virtual threads. And this is something which is very famous now. Everybody's talking about it. And the thing which is necessary to keep in mind, they are cool and nice, but they are not the silver bullet. They don't solve all our problems. So if you are interested, I can show the samples I did to play with the requests and responsibility. So I will show it. Share screen.
Sure. Let's see it in action. Yeah.
Thank you. So I wrote a simple thread, threaded web server with very simple requests. In the beginning, lots of the tests only try with thread sleep, but this doesn't show us the real performance of the test, because just doing nothing doesn't simulate the real situation. So what I did is that I tried to connect to local database and read some file, and then put some output, and it's done. So I played with the way how to respond or how to implement this thing. The first implementation is without any threads. So the request is accepted from the socket, synchronously handled, and executed. So what I will do, I will run the file. it's listening, and on a different computer, I will start 500 requests, synchronous requests, and I will run 10,000 of these requests. So
server without threads is a blocking operation. It takes the request, blocks. When it's done, then it returns to the caller. Okay.
Yes, exactly. So you see how it works. You see that each request is done by one, and there is nothing running in parallel, and the performance is very, very, very slow. So I will stop it because we are just in the middle, and the performance is about 184 requests per second, which is very slow. So what I will change is I will start playing with normal threads, something we call platform threads. So with every request, a new thread starts. So let's start this one.
And this is the threading on the plain old Java standard edition platform.
Yes, this is
okay.
Normal
threads.
Threads. Actually, it is the same when we have managed executor service as it is now. This is this example. It creates a new thread.
Okay.
No, not managed executor service, but factory. So
thread factory. Yeah.
It creates a new thread. So let's start. And we see that it started multiple threads at once. Before even the first started, it already started 120 requests.
Can you give a little explanation on what these numbers are? So for instance, the first column, I see numbers, and then there is the arrow, and then there's another number, then there is 10 running. So the running refers to the threads running.
Yeah. It took me some time to paint interesting statistics. So what I'm doing before I start, I increment the counter of started, and then I do the request, and when I finish, I increment the finished, and then I calculate the difference, and this is this number saying how many requests are running in parallel, and I remember the highest number. Just to know at the end what was the maximum parallelism. So we see that with typical platform Java threads, we got into 120 requests in parallel. And actually, there are about 40 threads running. The problem is that creation of the thread is pretty expensive.
Okay, so it's an expensive process, springing up the threads for the application to run. Okay.
Yes, this thing is expensive. The new thread is the expensive operation. So what's done, and this is the case of enterprise Java, is that we propose some pools, so we can provide numbers of threads. So for now, I will create 500 of them. The fun thing for this test is, that's why it's still in the middle, is that the database has about 100 connections available. So, and of course, for real application, there is a connection pool. So this is still just a test. So let's try with thread pool.
And so with this thread pool, go on.
Yeah, with the threads, we have got to some 750 requests. So this is thread pool, and I'll start the test again. And we see that the parallelism is significantly bigger. And sometimes it happens that the database refuses to join because there are too many connections. So this is something artificial for our case. But with the connection pools, we are able to get to the 500.
So this connection pool is the current feature available on the managed Jakarta EE platform where you can pool the threads.
Yes, if we do resource private managed executor service. So that we get managed executor service, which is set on the server, so we can influence the size of the thread pool, and sometimes also the way how it handles the waiting requests. And this is already existing thing. So this is what is already in so now we are getting to virtual threads. Virtual thread is something which is handled by Java itself. You probably heard a lot about it. So for this example, I don't limit the number of requests, and I simply get any request which will come will be handled without any limitation. In reality, we will limit it, because as you will see, I can increase the number of requests, but it will actually behave worse, because it will totally overload the database. So this is not the purpose. So let's start with threads, run the file, and run the test. So what you see is that you get the problems with the database much faster. Almost immediately, you get the issue with too many requests. And this is the thing, that this start virtual thread is very cheap. It starts very quickly, and you get very quickly to high number of the concurrency. So, you know,
so unlike platform threads, starting a virtual thread is very, very lightweight, if I should put it that way. And so you have a lot of it much more faster. Okay.
So you see that it behaves very similar to the thread pool. The performance is similar, something about 800 to 1000 requests per second, but it behaves very. These things are running very, very much in parallel. The big difference is that with the thread pool, there are 500 threads, and they are there all the time. Since the beginning of the application, they exist and they occupy memory, and they are there all the time. If you want to create another thread pool, and you want to have another 500 threads, there will be 1000 threads in the memory, which is not very good. So for this purpose, the virtual threads are much nicer. This is something which will come in Jakarta 11, the one we are working on, and the change will be with the I don't remember exactly. With the definition of the managed executor service. And the only change is that you will put virtual equals true to the definition, and you are done. Your threads will be virtual, and therefore they will run very quickly. So what we have seen so far, it starts quick and nice, but it's not more powerful. What's necessary to keep in mind is that virtual threads don't help if you do some CPU intensive thing. If and I will show it in some further demos later, not today, in some future. If this handler request calculates something or does something CPU intensive, it will be it will stop the virtual thread, and the threads which executes these virtual threads, it will block it for longer time, and the performance can be slower. The performance can be lower. So definitely it's not good for computations. And then it may happen that if you are using a database and the database is the bottleneck, then virtual threads don't help you, because it will make even bigger push to the database. So that's not good. Where this is very good is if you are doing some small tasks, and so that the startup time is important for you. So then it makes very big sense to use virtual threads. And if you have something which waits for a long time, so for the remote resources, especially if you have some, say, seemingly infinite performance behind you. So if you are creating a microservice and you are calling other microservices, definitely it makes sense to run them in virtual threads, because they will start immediately, block on the remote call, and then return. And the overhead of the virtual threads is much lower than the platform threads. I have one more demo, but I'm probably too long now. With the visual VM, it's nicely visible that when I run with platform threads, all 500 threads are occupied and running at the same time. And if I run on virtual threads, there are only 12 threads, 12 system threads, which are running. So if we will have some time at the end, I can show this demo.
Yes, I do have a few questions here, which I think the audience will also have. Back to the platform thread that you you started with the thread pool. So for that 500, all those 500 threads are created and kept in the pool, as you mentioned. Yes.
Mm-hmm.
So we have 500 of these in the pool. But then for the virtual threads, we have them being spawned a la carte, as and when there's a demand, and then they are started.
Sorry.
Yeah, I mean, the virtual threads, this thread here, these platform threads are created upfront and kept in memory.
Yes.
Okay, but the virtual threads, they are created on the fly.
Yes.
Okay.
They actually, if I create this pool, they are created and remain there during all the running of the program. If I use the Loom threads, there are created only the virtual threads that already exist. In my case of 12 cores, I have there are 12 carrying threads, which are platform threads, and when there is some virtual threads, one of these carrying threads are taking the workload, execute the virtual threads, and when it's finished, they go back to the pool. So the thread pool of the carrying threads is the size of the number of CPU cores. Okay. So usually much lower than any thread pool used in Jakarta service.
Okay. And like you mentioned, so the virtual threads are much more suited to cheap operations that you want to run very fast, but are not very CPU intensive, if I understand correctly.
Yeah. This is example of this code. This code actually, what it does is to tries to connect, and this is the thing where the thread blocks. And if it is normal thread, platform thread, it stops and waits. And when the connection is created, it goes further, gets here, and stops again, and it is still there. In case of virtual thread, when the carrying thread comes here, starts waiting, the carrying threads disconnect from the virtual threads, put it to the queue, and starts working on some other virtual threads if there is some work. And when this connection is the database connection is connected to the database and wants to continue, the carrying threads picks up these virtual threads, does the next step, and again when it stops, it returns it to the queue. So the same amount of work can be done in just 12 threads instead of 500, and doing the same job.
Okay. Okay. So effectively, they are really not they are not necessarily replaceable. So virtual threads won't necessarily replace platform threads. They all have their places in an application.
Definitely. That's the nice thing, that the specifications decided not to replace all of the threads with virtual threads, because imagine that you have, I'm preparing some sample with painting motherboard pictures, which is simply CPU intensive. If I will create virtual threads painting 1,000 of these pictures, this will blocks the carrying threads, and any other piece of code which will use the same threads simply will not get the CPU time. Because the thing with the virtual threads and the carrying threads is they are not preemptive. They don't stop until the virtual thread stops. You see, my thread, the handler request stops here, connecting to the database, here executing the query, here it tries to load a file, here. It stops, waits until the file is read, and then returns back and continues. Writes probably can wait for some time, or this flash, and then it creates these things, and the thread is done. So if this will do the calculation for a long time, no other virtual threads will be able to use the same carrying threads.
So effectively, a given virtual thread will simply sort of lock down this particular block until it's done.
Yes.
Okay. Okay. So virtual threads and platform threads, very interesting, because there's been a lot of gives and takes and different opinions online about the magic of virtual threads and all that, but it seems to be a little bit different from the numbers your test is putting out here.
So here I use I do the example which creates video from the pictures. So this is one microservice, this is another microservice, and I am trying to submit this task to create the picture. If this is calling microservice, then it makes sense to use this thread pool as virtual threads, because they basically do nothing. It doesn't make sense to have 100 system threads waiting and then do nothing. So virtual threads are perfect fit here. If I do the actual painting here, so occupying CPU for say 1 second, it means that only 12 pictures can be done at the same time, and that affects the overall performance. So, for example, if these 12 pictures are painted, it means that if there is some other service wanting to do something unrelated, it's not allowed, and the JDK will keep these carrying threads occupied doing the calculation. So it's a bit dangerous thing. It's necessary to really think how to use the virtual threads so they don't block each other, and what's the load, where to use it.
So if I understand correctly, the virtual threads are very much suited, at least in an enterprise application configuration like this, they are very much suited for sort of fire and forget operations and not very heavy operations.
Yes, exactly. For heavy operations, it's definitely much better to use normal platform threads, as in this case. This is actually, oh Jesus, this is Jakarta EE.
Okay.
Mm-hmm.
So in EE11, Jakarta EE11, virtual threads are also going to be sort of incorporated into the managed executor service. And then we can determine that we want you to run this particular thread as a virtual thread or as a platform thread with that flag you mentioned.
Yeah.
Nice. Okay, so now the numbers don't lie, as they say in my part of the world. The numbers are always the single source of truth. Now that we know virtual threads are suited for a specific kind of operation and platform threads are suited for another kind, I just want us to take a quick look at application performance in general. I think for us as developers, we mostly look outside when it comes to application performance. So my application has to be performant. I should be able to do X, Y, Z. So let me use virtual threads or this thread or that thread. What factors, what pointers do you have for us developers when it comes to application performance in the application itself? What are some of the do's and don'ts you can give for us to write much more performant application independent of even the threading? Before we think about threading, what are some factors you can give?
First, it's necessary to know where is the bottleneck. So if the bottleneck is the database, doesn't make sense to care about virtual threads and any threads, because the database is the bottleneck. Thinking about virtual threads makes sense at the moment when your application doesn't really use all the power of your hardware. So your background cluster or cloud of microservices or the database is able to handle more requests, but the blocking point, the bottleneck is your concurrency. So your number of requests you can handle. If your thread pool is becoming too big, so it contains hundreds or maybe 1,000 threads, which start to be a bit difficult to handle, then it makes sense to think about virtual threads if they can handle the job which mostly wait. This is the key message from the JDK developers. Virtual threads are great in waiting. So if your threads are mostly waiting, it makes good sense to make them as virtual threads and then decrease the number of threads which are all the time available. They exist in memory. So it's nice to get rid of them, run with 12 threads, and save some memory and make the concurrence a bit faster. The interesting thing is that when you look at the demos, you see that we are able to run millions of threads because it's cheap. It almost doesn't consume any memory, etc. Sounds good. When you try to do it, the first thing you get is out of memory or out of connections or out of any resource. The first resource which you meet will get out of it. I tried, for example, some performance tests of Payara itself, of the connections, and the thing I found is that there is limited number of concurrent connections. And then the server refuses to connect. And actually, it's a feature of the socket itself. Something I didn't know before, because yes, the first thing is, okay, I want to create as many connections as I can. I ran it naively, simply create connections and run all of them. And then I realized that the virtual threads are free to run 10,000 threads at once. And obviously the limit of the socket is something like 5,000. So immediately 5,000 of the connections fail. So this is my first experience with virtual threads. Of course, if you want to do anything, you consume some amount of memory. Like with the Mandelbrot pictures, I paint some, say, 1,000 by 1,000 picture of it. So when you start with 10,000 threads, you immediately get out of memory because everything immediately starts to occupy memory. So this is something you really need to be careful. So they very quickly start. They start so quickly that the other resources cannot follow your speed. So back to the question, where it makes sense, if you have some microservice which calls other microservice, it definitely makes sense to have virtual threads. If you are accessing database heavily, it makes sense to create virtual threads, because then your threads don't need to follow the number of your connections. Welcome back.
Bookman's back.
Sorry, Zoom just crashed. Yes, Zoom just crashed on me. Yes.
That was a quick return, though.
Yes. Yeah, it just crashed. Yes. Yeah. So from the answer you gave earlier, Peter, so if one of the guiding principles to know when to choose virtual threads and when to choose platform threads is, if I realize that I am packing a lot of platform threads, I create threads and then they are packed, platform threads, and then I find my application packing them, then it's a good sign that I probably will be better off using virtual threads instead of the platform threads, because as they are packed, they are consuming memory, and virtual threads are very cheap to spawn, to just simply fast fire and forget kind of starting.
Yes, I would say whenever your thread pool is big and you are fine with this, like 500. So if you are able, your application is fine to run 500 parallel threads, then it means that it is waiting for something. If you calculate something and you use 500 threads, your application stops because it doesn't compute anything. So if your thread pool is like 5 or 10 threads, then it's obviously something you calculate, and you need to limit the number of concurrency, the size of the concurrency. If your threads are big, then obviously you are the threads are mostly doing nothing or waiting mostly. So it's good sign to use virtual threads.
Okay. I'm finding myself learning a lot because there's a lot of talk out there about virtual threads, but without numbers. And like you mentioned, I also saw them spawning up to 1 million virtual threads, and I was wondering how realistic that is for a given application.
Yeah, I hope that I will be able to demonstrate that it uses less memory. But in my simple example, it actually uses a bit more memory. So I cannot prove that it's better. But this is too simple example. So once we will have the better implementation in the server, currently I have some sample I did a few months ago, but currently we are working on a proper implementation. So we will be able to show how it really helps, how it works, and of course I'm currently developing sample application to show what's the advantage and where it helps. When you will do your own tests, what's absolutely necessary is to run the tests on different computer. When you run it from the same computer, it's a problem because your testing application, like I'm using simply Apache Benchmark, it starts 900 or 500 threads, therefore it occupies the whole CPU, and then it's difficult to measure how good is to use it from the server side, because it occupies another 500 threads. So it's necessary to do it from another computer, and the test I'm going to prepare is that I want to have to call different computers. So on my computer there will be only the threads and calling either database or microservices on another computer. So it should simulate much better microservice architecture, and the actual setup web database is usually on different computer. So this is something I need to continue. I didn't it so far, and this should better show the power of virtual threads.
Okay, so in essence, it's always measure and be sure exactly where the bottleneck is, and then fix the bottleneck first. Because without fixing the bottleneck, like a database bottleneck, no amount of threading will. There's a comment here from Petro. He says the operating system which hosts the application has its own limits, like the sockets you mentioned. When using virtual threads, we can always throttle the number of virtual threads using those operating system resources or other resources. I'm not so sure if I fully follow, but as a rule of thumb, I'm not so sure if I want to tweak constraints and domains that would need that. But I don't think for normal applications, I want to go down to the operating system level and be tweaking stuff with sockets and all that. I don't know what you think about the comment.
Yeah, I see the comment. This is something I played with it as well, so I'll share again. This is the file I didn't open, this one. Room limited. So I did the limitation of the threads. The database uses 100 or the maximum of the connection is about 100. So if I will put 90 or 100, so I can try the same. If I limit the number of virtual threads, it makes sense, and this is something we are going to do in Payara definitely, because what may happen is that developers will think that it is the silver bullet solve everything. So they will use the virtual threads everywhere, and what will happen immediately is the out of memory, because 1 million of requests will definitely kill it. So we will do some semaphore limitation definitely, and then it's matter of setup of the server. If the number is 100, 1,000, 100,000, it depends. So even if the application will be too dependent on the virtual threads, we will be still able to limit it on the server. So I absolutely agree. It's necessary to limit it in reality. But the thing is, okay. So first, you see that the maximum concurrency is full. So what we allowed. The performance is like 860 requests. So very similar to the limit. Obviously, because the database connection is not that doesn't go beyond the database connection. You don't see any errors like we saw with the unlimited. Obviously, it slows down the connection. My implementation tries to repeatedly ask the database. It's just sample. So definitely, it's necessary to limit it so it doesn't go crazy. But what is nice is that you can have in your application, you can have different pools, and you can do different types of tasks on different pools. You can have several managed executor services definitions or thread factories, and for things which are fast and don't consume much memory, simply use virtual threads. For something which will be limited, use different pool which will be limited. So this is something which is good for usage in the Jakarta applications.
Okay, there is another question here.
Yeah, when I'm sharing, I don't see it.
Yeah, it's in the comments.
Stam says, over time, I have come based work. If I recall correctly, it is also done using a thread pool for each type of work. Would it be bad? Would it be a bad idea to create an IO-based thread pool, which uses entirely virtual threads?
Peter, if you look at the chat, you can read the comment as well. That might be easier just to read it yourself as well.
I am better in reading.
Yeah, that's it. That's what I usually recommend as well. You can read it out loud, but sometimes it's just better to have a look at it.
Great. IO-based thread pool, which uses interrelay. I would try it. I think it's good. The question is if the reading is very fast. When I started to develop this application, I was thinking about something that will be slow. So I started with the reading files, and I thought that it's fast, it's slow, and then I realized that it's actually very fast. Especially in my case, it's still reading the same file, so it's obviously in the system cache, and so at the end everything happened in the memory. And not sure with the case of SSD disks if they are not too fast, so it doesn't make big sense. I'm thinking about things which go through the TCP, like the database calls or other microservices. This makes bigger sense because it takes longer. In disk IO, I'm not sure it will help much.
Okay.
There is still the risk of creating too many requests. So if I did it, I would definitely limit it to some number from experience. So if I'm doing Jakarta application, I always depend on the resources defined by the server, because it can be different in every deployment. In every server can have different conditions. So, some of the IO can run on SSDs. Some of some clients can install it and access arrays of the spinning disks, and the behavior is different. So if you allow thread pool, they have the possibility to influence the number of concurrent threads. And what's planned is that in Jakarta 11, the users, I mean the admins of the server, will be able to say if the thread factory will use the virtual threads. So if you are developing Jakarta application, you have the option to use virtual threads in your definition, but also you can develop the application with just managed thread factory, and then set up on the server in the final deployment that it should use the virtual threads. So it's not only developer's decision, but also the administrator decision at the end and the final server. This is something that's planned to.
Thanks. Okay, if there is a final question. Yeah, go on, please.
Final thought. If you are using Jakarta, maybe you don't need to do anything. Just depend on managed executor service or managed virtual thread factory, and then set up on the server that it should use virtual threads, and you don't need to do anything. And just measure if it was worth it or not.
Okay, so in the end, just measure and be sure, let the numbers make the decision.
Exactly.
There is a question, a final question that says there will be, I think what Esteban is asking is how to get hold of the virtual threads in the managed environment. He's asking, there will be a managed platform thread executor service or a managed virtual thread executor service in Payara or Jakarta. I think he's trying to ask how the managed executor service is going to be amended from the API perspective in an application. How do I determine the managed executor service should run on a virtual thread or a platform thread? I think there will be a flag also in Jakarta EE 11.
Yeah, there's some more discussion actually going on in the comments as well.
Yeah.
No, that's good. That's good. I mean, we're almost at the hour, but if people want to chat, we can go over. Maybe not for too long because I appreciate people's time. But yeah, I was saying these are quite wide topics, aren't they? We can run another couple of events on this. Yeah, I think everyone is reading the comments.
And service.
What Petro wrote is exactly the case. The carrier threads are working until there is some wait, some interruption. Then it disconnects from the virtual threads and moves it to the queue. Yes, it will be. I actually need to find. Sorry.
I will also share the blog you wrote on the virtual threads here.
Please.
So, because I think everything is in there. So let me just share this blog here. It's about virtual threads in a Jakarta EE context so that everybody will get an idea of what's coming in Jakarta EE 11 vis-a-vis virtual threads.
Mm-hmm. So I will share the it looks. Yeah. Here is the description of what are the virtual threads, and this is how it is working now. So whenever you want to have a new thread, you use the resource. What I usually use, this is default, so you know. Okay, this way you can specify the name of your definition of the managed executor service, and or you can provide your own. So if you will provide in Jakarta 11, you will provide this definition and say virtual true, then they are virtual. If not, they are by default the platform ones backward compatible. But what you can do is simply leave it on the server setup. So in the server setup, you will be able to specify the number of threads and if it is virtual or not. And this is what I prefer, because this allows the actual setup to influence how your application behaves. So if it will be using virtual threads or not is not the decision of the programmer, but of the final admin of the server. If they will measure that it behaves better with virtual threads, they can set up virtual threads. If they will decide that it's running better with, say, more or less platform threads, that's again their decision, and you don't need to solve it. It's just you should be aware of these things. So good idea is definitely to separate the load to two different pools and move the different load to each of them. So have one thread pool for long tasks and other thread for something I don't know, waiting tasks, some communication with database or microservices. So it's not necessary to have all the still open.
So effectively, your recommendation is to leave the whole configuration of virtual threads or not to the servers, just as we've been doing for database resources and all that. We should leave that configure that in the server, and then there can be applications who automatically be using that as long as it's configured in the server, rather than configure per application basis.
Yes. For us as developers, we want to influence it. So we provide the configuration, and then we say, yes, my application supports virtual threads. It helps. It's faster, or it's usually not faster. It's usually it has higher throughput. So if you tested this, then it makes sense for your deployment to follow your advice. And you test it locally usually, so you know that it works, and then it's up to the admin of the server that he can influence it as well. Either deciding that his setup is different, if he runs on, I don't know, big servers, smaller servers, running on. One of the things we are considering is we don't know what will Java support or will provide in, I don't know, 5, 7, 10 years, and we are developing compatible implementation. So what I showed with the virtual threads is currently only a suggestion. So the server may run the threads in platform threads, not virtual threads. So it's still fine. It will still work, and the idea is, because it's already, I don't know, third attempt of Java to play with, to introduce more performant threads. So it's not sure what will be provided in 5 years, so maybe there will be better way in 5 years. So set virtual threads is just advice. Maybe in the future there will be better way, so the servers will run the old applications in this better way. So it's not always saying it must be done in virtual threads. So this is somewhat careful approach we chose.
Okay, nice. I think we're at the top of the hour, so we just hand over to Dominika to give us their closing remarks. There will always be things to discuss about threads, so I think we will schedule another one and then continue this particular discussion, because there is a lot of interest in this. Yeah. So over to you, Dominika.
Thank you very much, Peter. Thank you, Lukman. Once again, really interesting and really good conversation that breeds more ideas for more events like this. So I really appreciate and I really appreciate the discussion in the comments. Thank you very much for that. That keeps the conversation alive, and it's we know it's not just one-sided and what's coming from us. We really need your input there. I will quickly, before we wrap up, I will quickly launch a very quick poll, just so that you can give us some feedback about whether you found this event useful. So yeah, I just wanted to let you know that we are running those events regularly. Like I said at the beginning, we will be announcing a new webinar very shortly in the next couple of days. There will be another couple of webinars coming in the next few weeks. And we also actually have a Payara virtual conference that we would like to invite you to, which I'm going to send a link to in the chat in a moment as well. Also, in regards to the other Java 21 content, I'll quickly share my screen so you can see where to find it, because we've got quite a lot of that. So let me, right, there we go. Okay. There we go. So this is our blog. So if you are not subscribed yet, please, I do encourage you to go to blog@payara.fish. Very quick way to subscribe, just here with your email address. We've got this at the top, has just been posted today. So if you click on Java 21 tag or a topic, you will find lots of other resources, lots of other articles that Lukman wrote. There's also a couple from Peter as well, and a few more from earlier this year. So if you want to, expand on what we've discussed today, then head over to the blog and you will find lots of content there as well. And in regards to the virtual conference, I have just shared the link with you on the chat, in the chat. So have a look. We're running it on the 14th of December. You can register and pick whichever talks you want to attend. You can also watch them on demand after. So if you're not available on the day, or if you don't have time to watch everything on that day, you can also watch on demand later. So I definitely encourage you to check it out. We will be talking about Jakarta EE and the future of Jakarta EE, the future of Payara Platform in the context of Jakarta as well. So yeah, I think that's all for today. We already, 7 past the hour. So thank you very much again. Thanks for your involvement, and we hope to see you again in the next couple of days or weeks for our other events. So keep an eye on the blog and you'll find out more about what's coming. All right. Thank you very much. Thank you again, Peter. Thank you, Lukman. And everyone have a good afternoon. Have a good day. Bye.
Thank you. Bye.